In this video, we're going to prove the trig identity cosine x minus sine x over sine x times cosine x is equal to cosecant x minus secant x. So the general strategy is you want to pick the more complicated looking side, and you want to work on that side using algebra and trig identities to make it match the other side of the equal sign. So for this case, I would argue that the left-hand side is more complicated. And so what we're going to do is we're going to work on the left-hand side to make it look like the right-hand side of this particular equation we've got. Now, the first step, and generally I always do look for some sort of algebra trick that I can use on the first step, and a lot of times it's going to be a factoring, maybe out the greatest common factor out of all of your terms. But for this particular problem, what I'm going to do is notice we only have one term on the left-hand side. So all that is one big fraction, so that's one term. And on the right-hand side, we have two different terms. And this is something to look out for, because anytime you want to break one term into two terms, you want to see if there's some way you can break up the fraction into two different fractions. And so to do that, we're going to use algebra, and we're going to put each of the terms in the numerator over the denominator. And so that will give us cosine x over sine x cosine x. And that's going to be minus sine x over the sine x cosine x. And so all we did is we used algebra for that first step to break one term into two different terms so that we match the number of terms we have on the right-hand side. And this is a common thing to look out for, so always, anytime you can do that as your first step, you may want to do it. So now we're going to also use algebra in our second step. Notice we have a cosine x on top and bottom in our first term, and we have a sine x on top and bottom in our second term. And so then just rewriting what we have left over, in the first term we have 1 over sine x, and that's all we have, minus, and in our second term we're going to have 1 over cosine x, and that's all we have. So we haven't used any of these identities yet, but the next step is going to use these identities, because if we kind of look back and see what we want to match up to, we want to have cosecant x minus secant x, and right now we have everything in terms of sine and cosine. So we're going to take advantage of our reciprocal identities. So 1 over sine is the same thing as cosecant, and 1 over cosine is the same thing as secant x. And so all I'm doing is trading out the 1 over sine x for cosecant x, and then minus the 1 over cosine x for secant x. And that's it. Now we match. We have cosecant x minus secant x, so we made the left-hand side turn into that, and so that verifies or proves that it does equal the right-hand side, which was cosecant x minus secant x. And that's all. So notice for this problem, it looked pretty scary in the beginning, but anytime you only have one term and you need to break it into multiple terms, breaking up the fraction into two different fractions is typically going to be the thing you want to look to do. And then what you want to do is you want to simplify whatever you can. And in this case, we used very minimal amount of the trig identities on the right-hand side, but we did have to use them for the last step.